Good afternoon to all. Last day we have learned about the concepts of congruence and some properties of congruence. Today we have to do some problems of congruence. The first problem, show that 4 raised to 2n plus 1 plus 3 raised to n plus 2 congruent to 0 mod 13. So for that we have to, if A congruent to B mod C, then A minus B is a multiple of C. That we are, this is the concept of congruence. So we have to show here that 4 raised to 2n plus 1 plus 3 raised to n plus 2 is a multiple of 13. So we can take 4 raised to 2n plus 1 plus 3 raised to n plus 2, which is equal to 4 raised to 2n into 4, a raised to m plus n is a raised to m into a raised to n plus 3 raised to n into 3 square. So here we can write 4 raised to 2n as 4 square raised to n or 16 raised to n into 4 plus 3 raised to n into 3 square. Now we have to find this is as a multiple of 13. So we can write 16 raised to n is 13 plus 3 all raised to n into 4 plus 3 raised to n into 3 square, which is equal to, now we know the binomial expansion of 13 plus 3 all raised to n, which is equal to 13 raised to n plus nc1 13 raised to n minus 1 into 3 plus nc2 into 13 raised to n minus 2 into 3 square plus etc. The last term is 3 raised to n all into 4 plus 3 raised to n into 3 square up to this term. This is 13 raised to n, next term 30 raised to n minus 1, next 13 raised to n minus 2 up to this term is multiple of 13. Here it is 13 raised to 1 will be there into 3 raised to n minus 1. So this is multiple of 13 plus 3 raised to n into 4 plus 3 raised to n into 3 square is 9. Now multiple of 13 into 4 is again a multiple of 13 plus 3 raised to n into 4 plus 3 raised to n into 9, which is equal to multiple of 13 plus 3 raised to n into 4 plus 9, which is equal to multiple of 13 plus 3 raised to n into 13. So which is again a multiple of 13 plus multiple of 13. So it is a multiple of 13. That is 4 raised to 2n plus 1 plus 3 raised to n plus 2 congruent to 0 mod 13. Next problem is, show that 3 raised to 2n plus 24n congruent to 1 mod 32. So for that take 3 raised to 2n, which is equal to 9 raised to n 3 square raised to n, which is equal to 8 plus 1 all raised to n, since 3 raised to 2n is equal to 3 raised to 2 all raised to n. 8 plus 1 all raised to n is n, 8 raised to n plus nc1 8 raised to n minus 1 into 1 plus nc2 8 raised to n minus 2 into 1 square, which is again 1 plus etc. n minus 2 8 raised to 2 into 1 raised to n minus 2 plus n minus 1 8 into 1 raised to n minus 1 plus last time 1, which is equal to up to here, this time up to 8 square. 8 square is 30, 8 square is 64. Up to this term is multiple of 32. 8 cube is 8 into 8 square. So this is multiple of 32. So 8 raised to n is multiple of 32. 8 raised to n minus 1 is a multiple of 32. Up to 8 square is a multiple of 32. Now n minus 1 is n into 8 plus 1. Therefore 3 raised to 2n plus 24n is equal to multiple of 32 plus 8n plus 1 plus 24n is equal to multiple of 32 plus 8n plus 24n is 32n plus 1. So 32n is a multiple of 32. So these two terms again a multiple of 32 plus 1. Therefore 3 raised to 2n plus 24n congruent to 1 mod 32. Next problem is show that 2 raised to 20 congruent to 1 mod 41. We know that the power of 2 near to 41 is 2 raised to 1 is 2, 2 square is 4, 2 cube is 8, 2 raised to 4 16, 2 raised to 5 32, 2 raised to 6 64. So 2 raised to 5 is near to 32, which is 32 is 32 plus 9 minus 9 mod 41. 32 plus 9 is 41. 41 is a multiple of so 32 is congruent to minus 9 mod 41. That is 2 raised to 5 congruent to minus 9 mod 41. It's equation 1. If A congruent to B mod n, then A raised to K congruent to B raised to K mod n. This is a property of modulus congruence. So 2 raised to 5 all square congruent to minus 9 all square mod 41 is equal to 2 raised to 5 all square is 2 raised to 10 congruent to minus 9 all square is 81 mod 41. Now 81 is, we can subtract the 10 multiples of 81, which is congruent to 81 is minus 1 mod 41. So this is, we could write 81 into 2. Sorry, 41 into 2 is 82, or subtract multiples of 41. 81 minus 41 is 40. 40 minus 41 minus 1 41. This is equation 2. Now again use the property. If A congruent to B mod n, then A raised to K congruent to that is 2 raised to A raised to K congruent to B raised to K mod n. 2 raised to 10 congruent to minus 1 mod This is equation 2. Now take the power of 2. We require 2 raised to 20. So 2 raised to 10 whole square. 2 raised to 10 whole square congruent to minus 1 whole square mod 41, which is equal to 2 raised to 10 whole square is 2 raised to 20 congruent to minus 1 whole square is 1 mod 41. This is we have to show. Next problem is find the remainder when 2 raised to 1000 is divided by 17. 2 raised to 1 is 2, not near to 17, 2 square 4, 2 cube 8, and 2 raised to 4 is 16, which is near to 17. So we take 2 raised to 4, which is equal to 16 congruent to 16. Next 16 plus 1 minus 1 mod 13. 16 congruent to minus 1 mod 13, that is 2 raised to 4 congruent to minus 1 mod 13, 17 mod 17. This is equation 1. Now we have to find the remainder when 2 raised to 1000. So take power of 250. So 2 raised to 4 raised to 250 congruent to minus 1 mod raised to 250 mod 17. So if A congruent to B mod n, then A raised to K. Reason is if A congruent to B mod n, then A raised to K congruent to B raised to K mod n. So 2 raised to 4 raised to 250 is 2 raised to 1000. Minus 1 raised to 250 is 1 mod 17. That is when 2 raised to 1000 is divided by 17, remainder is 1. Next problem is when 3 raised to 247 is divided by 17. We can take 3 square is 9, which is 8 difference from 17. 3 raised to 3 is 10, so we can take 3 square is equal to 9 minus 8 congruent to 17. 9 plus 8 is equal to 17. So 3 square, that is 3 square congruent to minus 8 mod 17. Now 3 square all square is equal to 64 mod 17, which is we can subtract the multiples of 17. So 34, this is minus 4 mod 17. The 68 is a multiple of 17. So minus 4 mod 70, or that is 3 raised to 4 congruent to minus 4 mod 17. Now again take the power of 2. 3 raised to 4 power 2 congruent to minus 4 all square mod 17. So which is equal to 3 raised to 8 congruent to minus 4 whole square is 16 mod 17, which is equal to minus 1 mod 17. We have to show that 3 raised to 247. So 3 raised to 8 all power 247 is, that is 3 raised to 8 congruent to minus 1 mod 17 minus 2 3 raised to 8 raised to 30 congruent to minus 1 mod 30 raised to 30 mod 17, which is equal to, that is 3 raised to 240 congruent to 1 mod 17. In between, this is now we have to find 3 raised to 247. 3 raised to 247 is 3 raised to 240 into 3 raised to 6. 3 raised to 4 into 3 raised to 2 into 3 raised to 1 congruent to 3 raised to 240 is 1 into 3 raised to 4 is congruent to 1. 3 raised to 4 is minus 4. 3 square is minus 8. 3 raised to 1 is 3. 3 mod 17, which is equal to 32 into 3. Here 3 raised to 247 congruent to 32 into 3 is 96 mod 17. Now we have to subtract the multiples of 17. So which is equal to congruent to 17 into 5 is 85. So this is a 11 mod 17. We subtract the multiples of 17. So 96 minus multiple of 17 is 85. It's equal to 11. That is 3 raised to 247 congruent to 11 mod 17. That is when 3 raised to 3 to 247 is divided by 17, remainder is 11. Next problem, find the remainder when 16 raised to 53 is divided by 17. 16 is equal to 2 into 7 plus 2, that is 16 congruent to 2 mod 7. Now 16, we have to get a one value in the right side, 1 mod something. So 2 cube is, we know that 2 cube is 8, 8 is 1 mod 7. 16 cube is equal to congruent to 2 cube mod 7. That is, which is congruent to 8 mod 7. Now we can subtract the multiples of 7, which is congruent to 1 mod 7. That is 16 raised to 3 congruent to 1 mod 7. Now we have to get 16 raised to 53. For that, 16 raised to 3, consider 16 raised to 3 raised to 17. 3 into 17 is 51, congruent to 1 raised to 17 mod 7. That is the first one is 16 congruent to 1. Now 16 raised to 51 congruent to 1 mod 7. This is 3. We have to find the remainder of 16 raised to 53. We have 16 raised to 51 is there. Now into 16 square. We know that 16 congruent to 2 mod 7. So 16 square congruent to 2 square mod 7. Since 16 congruent to 2 mod 7. So this is, that is 16 square congruent to 2 square is 4 mod 7. This is equation 4. Now we have to multiply 3 into 4. 16 raised to 51 into 16 square congruent to 1 into 4 mod 7. That is 16 raised to 53 congruent to 1 into 4 is 4. 4 mod 7. That is the remainder when 16 raised to 53 is divided by 7 is 4. Next problem is find the remainder when 13 raised to 218 is divided by 17. 13 is, we know that 13 is 13 plus 4 equal to 17. So 13 is minus 4 mod 17. So 13 raised to 218 is minus 4 raised to 218 mod 17. Congruent to minus 4 raised to 218 mod 17. It's equation 1. So we know that minus 4 whole square is equal to 16 is congruent to 16 minus 1 mod 17. So 13 raised to 218 congruent to minus 4 whole square, the whole raised to 218 is 109 mod 17. That is 13 raised to 218 congruent to minus 109 mod 17, which is congruent to minus 1 raised to 109 is minus 1 mod 17. Now remainder is positive value. We will take a positive value 0 to 16. So add 17 to this number. So this will be 16 mod 17. Minus 1 plus 17 equal to 16. That is 30. The remainder when 13 raised to 218 is divided by 17 is 16. Next problem, find the remainder obtained when the sum 1 factorial plus 2 factorial plus 3 factorial plus etc. 100 factorial is divided by Next problem is find the remainder obtained when the sum 1 factorial plus 2 factorial plus 3 factorial plus etc. plus 100 factorial is divided by 12. We know that 1 factorial is equal to 1, 2 factorial 1 into 2 equal to 2, 3 factorial 1 into 2 into 3 equal to 6. 4 factorial. 1 into 2 into 3 into 4. The answer is 24. 3 into 4, 12 is a multiple of 12. Now 3 into 4 is 12. So 5 factorial. 1 into 2 into 3 into 4 into 5. This value is multiple of 12. So etc. Now 6 factorial is a multiple of 12. There also some 3 into 4 is there, etc. 99 factorial is a multiple of 12. 100 factorial is a multiple of 12. Therefore 1 factorial plus 2 factorial plus 3 factorial plus etc. plus 100 factorial is equal to 1 plus 2 plus 6 plus etc. 6 plus next term is multiple of 12 etc. multiple of 12. So this is 1 plus 2 is 3, 3 plus 6, 9. 9 plus multiple of 12. That is 1 factorial plus 2 factorial plus etc. 100 factorial congruent to 9 not 12. That is the remainder obtained when 1 factorial plus 2 factorial plus etc. 100 factorial is divided by 12 is 9.